Here we have a graph with some asymptotic behavior happening around, it looks like 2 and 4, and we're asked to evaluate a bunch of limits at 2 and 4. So let's dive right in. Part A asks us to find the limit as x goes to 2 from the left. Remember, this negative here means we're coming from the negative direction. Okay, so we're approaching 2 from the negative direction here on our graph, and let's see what happens with our function. It is going off towards infinity. Okay, so we would say that the limit as x goes to 2 from the left here equals infinity. Now, when we write the limit of some function, we'll say f of x, and we'll say as x goes to a equals L, that means that this number L is itself a real number. So we'll say element of the real numbers. That's what this symbol here means, element of. That means L is a real number, like 5 or 1,000 or a million, but not infinity. Infinity, the thing about infinity is it's not in the real numbers. Okay, so when we say that a limit is infinite, technically, by our definition of limits, that means does not exist. Okay, so we can write does not exist, but that's not how we really want to answer these, because that doesn't give us the information we want. We want to say that it's going off to infinity, and if we just write does not exist for this one, we can write does not exist for all of them. Right? But that doesn't give us much information about what's happening with this graph or this function. Right? It's almost like a nihilist answer of saying does not exist, does not exist. We just throw our hands up, walk away, and go sit in a coffee shop somewhere and be depressed, right? We want to answer more than just does not exist here, even though technically, if we chase the definition of the limit all the way back to this L having to be a real number, we could say all of these do not exist. So yes, they don't exist, but we want to give a little bit more information, so we're still going to answer these when we can with infinity or negative infinity, even though we all kind of agree that technically it doesn't exist, but let's still use the infinite answers. Moving on to part B, we have the limit as x goes to 2 from the right. So now we are approaching from the positive direction, from the right. Okay, so we're coming in from the positive direction. So now I'm tracing the function down. There it goes. It looks like it's going down to negative infinity. So again, this limit does not exist, but I'm going to write negative infinity instead of does not exist, because negative infinity is going to give us more information about this function. You may be saying, on the exam, which do I write, negative infinity or does not exist? Write negative infinity. There is one instance, though, where we do need to write does not exist, and here it is for part C. Part C asks for the limit as x goes to 2 of g of x. Now, a limit is said to exist if and only if the left-sided limit and the right-sided limit are equal. So here at x equals 2, we're flying off to infinity from the left and negative infinity from the right. So what happens at 2? It's going off into two different directions. So here we do say does not exist. And there's no way to write infinity or negative infinity to give us no information, because it splits there and goes off into different directions, which we often write as D and E. Looks kind of like 1, doesn't it? But that's a D. D and E does not exist. Maybe I'll put dots here. Does not exist. Okay. Moving on to part D, we have the limit as x goes to 4 from the left. So x is coming into 4 from the left. So we follow the function and see what it does. Looks like it goes down to negative infinity. So negative infinity, right? You start to get the idea here. As we come in from the right for part E, so now we're coming from the positive direction, which means we're coming in from the right. Come into x from the right, follow the function. Looks like it's going down to negative infinity. So here we also have negative infinity. Now for f, again, the function exists if and only if the limit from the right equals the limit from the left. Here they do, right? Both of these limits are negative infinity. They're both going in the same direction. So here we're going to say negative infinity. We write that instead of does not exist because they're going in the same direction. Even though technically this does not exist because this L has to live in the real numbers. So if you chase this definition down, that's not in the real numbers, so then it can't exist. But again, we're not going to say that. We're going to say negative infinity or infinity whenever we can, and we're going to reserve does not exist for this case where they go off in different directions. There'll be a few other cases where we need to say does not exist, but they're going to be very limited. Different textbooks will say different things for this, so it's a very subtle point on whether or not to write infinity or does not exist. So I hope that that's clear, that we'll write infinity or negative infinity wherever we can in our class, and then does not exist when the limits go in different directions.